Today we look at composition of functions. Okay, so this is another operation that we can do with functions. And what we will see is something like this, f of g of x. We can also rewrite it as f of g of x. Or if you can also say g of f of x, or write it like this, g of f of x. This open circle, it means composed of, or the composite of. It doesn't mean multiply. Okay, so what this is it's like two function machines. We're going to put a number into the machine. If we have the g of x on the inside, you're putting it into the machine, g of x. What you get out is some y value, and we're going to plug that into the next machine, which is the outside value, or the outside function, f of x. And then from there, you get out whatever, a new y value. Okay, so your output to the inside becomes the input to the outside function. So we're going to use the table here to figure out what f of g of 1 is. And so we can rewrite this. I always rewrite it. F is on the outside. We're composing it with g of 1. So on the inside part, I'm going to look at where on g of x is 1, and that would be right here. So I'll rewrite this. F of g of 1 is equal to 0. So now we're evaluating f of 0. So we're going to look at 0, and the f function would be 5. So the output is 5. So the output to one function becomes the input to the other. So next, g of f of 2. All right, this time I'm going to draw the machine. We're going to plug into the first machine. We're going to plug 2 into the first machine, and then the second machine, we're going to plug it whatever. Let's see, so we're going to plug it into f. So f of 2 is 1. So what I get out is 1. So g of 1. Now we're going to plug in to g, we're going to plug the 1 in to that rule. So now I got to go over to my table. At 1, g is 0. So g of 1 is equal to 0. Or we can say f of g of 2 is equal to 0. Lastly, g of 1. So again, let's go to 1 on our table. We're going to look at the output for 1 is 0. So I plug in my 0 here. Plug in 0. F of 0. Oh, g of 0, excuse me. G of 0 is, no, I'm saying this wrong, sorry. G of 1 is 0. So then I'm going to plug 0 into g. So I go to 0, and at 0, g is equal to 1. So again, g of 0, because the output for g of 1 was 0, and g of 0 is equal to 1. All right, the next part, we're going to find f of g of 1, but this time we're going to use our functions. Okay, so I always rewrite it f of g of 1. I'm going to start with the inside function here, g of 1. So I like to do this on the side. So g of 1 is equal to, let's see, 1 squared. So g of 1 is equal to 1. So I'm going to take this and plug it in for my output here. So f of 1. Now I just look at my f function, and I'm going to substitute in the 1 where there's an x. So the square root of 1 plus 2. 1 plus 2 is 3. And that's that. Next, we're looking at g of f of negative 2. So g of f of negative 2, where do we start? We start on the inside. So I do it on the side. f of negative 2 is equal to, and I'm going to plug in right here, the square root of negative 2 plus 2. And our function is undefined. So we get an undefined value. You can't take g of undefined. So this function breaks. What we would say is that negative 2 is not in the domain. It breaks the function. We can't evaluate. Okay? So this time we're going to compose the functions, just the functions themselves, and then we're going to look for their domains. There's some rules for domains. So what we're going to do is find the domain of the inside function. Then we're going to look at the domain of the final composite function. And then we have to combine the restrictions. Okay, so I'll show you what that looks like. For the first one, I'm going to figure out what the domains are first. So f of x is x can equal all real numbers, and the y's can equal, f of x, and g of x is x squared, so that can equal all real numbers as well. So we don't really have any domain restrictions on f or g, so we don't have too much to worry about. But when we combine them, sometimes we can get a domain restriction in the end, so we'll have to be careful there. Okay, so the next part is we're going to find f of g of x. So f of g of x, which I rewrite as f of g of x. Again, the inside is g of x. So I look, g of x, there's no domain restrictions. So I'm going to go ahead and just go for this. I'm going to have f of, g of x can be rewritten as x squared. And then I'm looking at my x plus 2x plus 3. So 2x plus 3. But anywhere there's the x, I'm going to replace that with my input here, my input x squared, which was g of x. So I get 2x squared plus 3 is equal to f of g of x. And I'm going to look at this and be like, 2x squared plus 3 is a parabola, and parabolas don't have any domain restrictions. So the domain for f of g of x would be all real values, or x can equal all real values. All right, next up, g of f of x. So again, rewritten, g of f of x. What is the inside function? It is f of x. Do we have any domain restrictions on the inside function? Nope, we don't. So we don't have to worry about that right now. So again, let's rewrite the inside as 2x plus 3. And the outside is g. So we're going to be plugging in 2x plus 3 into g. So I'm basically going to have x squared. And then I need to replace the x with the inside part. So 2x plus 3 squared. We'll multiply that out. 2x plus 3 times 2x plus 3 gives me, multiply. 4x squared plus 6x plus 6x plus 9. 4x squared plus 12x plus 9 is equal to g of f of x. Now again, we end up with a parabola, and parabolas have a domain of all real numbers. All right, last example. Let's get the domain of each. So the domain for f of x would be x's are, that's linear, so x's can equal all real values. And for g of x, x cannot equal, what can't we divide by? We can't divide by 0. So we'll be looking back at that in a second. Okay. And we're going to do f of g of x, rewritten to be f of g of x. So the inside is g of x. Do we have any domain restrictions on g of x? Yes. G of x cannot equal 0. So at the end, we're going to have to keep that in mind. So we have f of, replace g of x with its function, and then we're going to go ahead and plug 1 plus x into the function x minus 4. So anywhere there's an x, we're going to replace it with 1 over x. Okay, and that is equal to f of g of x. Now what I need to do is look at my final composed function, which is here in blue. Okay, is there any value of x that we can't equal? Well, again, I have this 1 over x, so x cannot equal 0. What I have to do now is look at the original. Is there anything from the original that isn't said in this domain restriction right here? Nope, so I don't need to add anything. Okay, so our domain restriction is x cannot equal 0, and the composed function is 1 over x minus 4. All right, last one. We're doing g of f of x. Okay, I always rewrite in this form, g of f of x. What is f of x? It's x minus 4. So we have g of x minus 4. I'm plugging in x minus 4 into the function g, which is 1 over x. So 1 over, instead of x, we are writing x minus 4. And that is g of f of x. Okay, so we're going to look at the original domains. So the domain of the inside is f of x is linear. So remember, f of x could equal all real numbers. There are no restrictions there. If I look at the ending composition, x cannot equal, what value can it equal to make a 0 on the bottom? Would be 4. So that would be our domain. This right here is my final answer. And that's it.